So we wait and we listen. And yes, there I heard everything. So I am broadcasting sound. Let's see if I am broadcasting music. Okay, so I'm sorry for that little 25-second lag. There is a 25-second lag between Ustream and live. What we were waiting for was to make sure we could hear today's recording. What I want to talk about first um, is um, inside the computer. And I see that we have something happen. Ooh, either somebody tuned in and everything went kerplunk, or for some reason, there we go, we're on air. Let's see if the air shows up. Got to remember there's a 25-second lag, and we'll see if we get through. I am not hearing anything on the computer, so well, we're live. Yes, hi, this is Tom Chianti. We're live. And everybody, or all I'm getting is a black screen. Um, hmm. Okay. So I'm asking if everybody's seeing the black screen. And telling you if so, refresh the page. And, there we go. I am back on. And the lag is a lot less. And it seems that we've caught on to a good line, net line, because the lag is much less. When the lag is that long, it's usually a sure sign that you're going to cut out. So as I was talking about, um, it's really the basics of your workflow. Always make sure you have in separate places backups of your current projects, and also in separate places, they can be the same separate two places, have archived copies of all your previous work. I had just the beginning of this month, I had both my backup drives fail and lost quite a bit of music. Fortunately, there was my private projects, and none of my clients' projects were disturbed because I have them on 3 separate discs. I have a total of 3, 4, 5 external discs and 3 internal hard drives. I've got close to like 5 or 6 terabytes of space that I divide and set up. And Always go to your disk utilities, have it check your computer's preferences. If you're on a Mac, have it refresh and check your preferences are working. And you'd be surprised how doing this once a month, these little basic jobs will make your workflow always go much easier. Your computer a lot less cluttered and a lot less failures, and especially when you start pushing it. Now I have an 8-core dual processor, 2.25 gig processing, gigahertz processing, two of them, Mac with 16 gigs of RAM. I've blown my little baby out, and right now that allows me to run 5 programs needed to do the webcasting. And so let's get back and talk about music. Let's take a quick listen to the project I have up today. Today is let's see how to get the most and make a simple 8 or 10 tracks sound interesting. So let's take a listen. Alright, and there you have the main part. Now we'll count the tracks. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 tracks. speed up, it keeps them linked together. And again, we have stopped broadcasting. I hate when this happens. I have to keep logging in, and believe me, I have to log in. I have my own recording of the show going on. For my purposes, I guess I'll just keep this going and hope that not everybody's getting a blank screen, and go on with the podcast purposes. Now, on these 2-inch machines, this master clock takes the time code from track 24, it's usually printed on each of the machines. And it makes sure the pulses on, off, lock together, or stop, go, lock together. We're back. Okay, that's good. So, that's sort of the basic theory which has followed over into the digital world. Your program, your DAW, your sequencer, works on a clock-based system also. It could be SMPTE, it could be SPDIF, it could be ADAT, it could be internal or external. I have an external time clock, which is a solid, pure crystal. It's a very expensive machine because this is a pro studio. And it's made by Apogee, and it's called Big Ben. And this crystal, very, very, very pure, sends out a pulse, and then the main clock sends it out through coaxial cables. They're special cables, and it goes to my converters and my computer, and it locks the computer with the converters so that everything plays back at the same time. Now you notice that some programs have problems, like your track will be in time and then you go to put a plug-in on it, and all of a sudden that track's delayed. That's because you're using extra processing time I'm just relogging in. You're using extra processing time. The signal has to go through the plug-in and then through the plug-in out to the sequencer and out through the converters. You've added another block in the chain and made the signal chain longer. So that's basically, and this is why I can basically look at almost any program and at least get it running. It's because I understand the basics. It's like physics. It's an amazing thing. Once you have taken a couple of years of physics and learned some basic rules and laws, you can pretty much figure out what's going on around you and why certain things happen. So that's why I'm taking the time to teach you this very basic stuff, because sometimes you may not realize that your stuff actually is in time, and all you have to do is stop the sequencer, the DAW, and start it again, and the program and the computer work together to make up that difference and goes back to the internal clock or your external clock and says, what time is it? And the clock tells them it's 00000123. And so many frames and so many subframes. It gets very, very exact. So that, and it has to be. Most professional studios don't use MIDI to time their clocks. They are sample accurate. And what that means is that every sample has a working bit length and a frequency. And in my case, I work in the ultimate end product frequency, 44.1 and 16 bits. Even though 24 bits and 96, it sounds better. It's all going to eventually get, the word is called dithered. And depending upon the type of algorithm you use, it'll either be a minimal loss or a great loss of signal. So it's the engineers, your choice, as to whether you want to work in the highest bit rate and frequency rate available to you to get it to sound the best it can to start off with, and then basically watch as it gets dithered down to 44.1 kilohertz sample rate and 16 bits. Now, you'll notice I'm doing a lot of talking because there's a lot of really basic information that once we get through, you really understand what those numbers mean. Now, the 16-bit tells you that there's 16 bits of information in the word. It goes bytes, bits, word, sample. Something like that. I'm not going to get extremely technical about it. One is I'm a little fuzzy. I'll be very honest with you. It's a lot of information up in this noggin of mine. But I will tell you this, that the 16-bit tells you the amount of information, 16 bits, 16 zeros and ones, that goes into making the word. And the amount, and the word turns into, that's what it's talking about, 16-bit versus 24-bit. 24-bit gives you 8 more bits of information per word, thereby digitally getting closer to the analog sound, because instead of just saying the man wore a blue shirt, you can now say the man had gray hair, blue shirt, and was wearing glasses. So the more information the computer has to deal with on a sample, going from 16 to 24 bit, it sounds better. Now the frequency, 44,000.1 hertz. That's how many times the digital machine samples in a second. 41,000 times it looks at the source of the signal. That's a lot. And now it goes up to 96,000, 96K. That is very close to analog sounding. It does sound, I mean, scientifically and logically and realistically, it sounds much better than 16-bit 44.1. Unfortunately, at 96K, it takes tremendous amount of megabytes and gigabytes of space to store just one signal. And if you're, making your record and your music, you're going to have anywhere from 10 to 30 to 60 different signals. That's a lot of room to take up in your RAM, to take up on your hard drive. So I find that for me, eventually it's all going to be broken down to 16-bit 41,000 times sampled. That I work in that. and I make it sound the best I can in that, so that what I finish sounds exactly what I did when it goes out and I send a copy to a friend, a WAV file or an AIFF file. It sounds exactly like what I did, rather than, gee, it sounds a little duller than it did when I originally did it. And that's because high frequencies come and go very fast. That's why they go up in numbers. You start at 0 hertz, which is, the null point on an oscilloscope. Let's call that 0. Below it is negative numbers. Above it are positive numbers. So every time the signal crosses that null point, creates a frequency, a repetitive signal. So 800 hertz per second, it's all measured in per second, is how many times the wave crosses over the null point. Now that's a big wave. Low frequencies are very big waves. In the physical world, you could take a 50 hertz signal, and the signal wave, if you could see it, is probably larger than the room you're in, depending upon the size of the room. So our ears can't hear the full 50 hertz, but we can feel it, and you can hear most of it, but you won't hear all of it because the room can't contain it. If you're in a treated room like I am, it contains the frequency, and basically what you have to do, and this is a curious thing, there's a thing called frequency saturation. If you're in your bedroom, and your bedroom's, small, 9 feet by 12 feet, and you're mixing very loud, you saturate the room with frequency waves. And that prevents you from getting a clear signal, hearing clearly. So it's always good, especially if you're mixing. Just, every couple of hours, turn the volume off, go out, take a walk. If you smoke them, if you got them, smoke them. Get out of the room, leave the door open so that the frequency waves can finish their flows, and when you come back in again, the room is refreshed. Now, I know that sounds like magic or mystery or weird science, but it's the truth when you get into the science of sound. And that's what I do. Basically, I'm a minor, very minor physicist, and I am an audio engineer, producer. So I know what the sounds are that I want to get. That's the production end, knowing how the finished project is going to sound, or at what stage you want to introduce what sound. That's production. Engineering is knowing how to treat the sound, capture it, and get it into the computer the best way possible, usually the shortest signal path. The most direct is the best, but depending upon your source, you have to do some very strange twists and turns in order to get there. So the shortest path, and you got to remember, you're dealing with electricity, because the audio signal gets broken down into an electronic wave. And this is why everything ultimately gets measured with oscillators and amp meters and volume meters and all sorts of equipment. And depending upon how manic or obsessive compulsive you are, you should have, if you have a mixing console, you should make sure everything's working together well and calibrated so that you have, let's say, 1 kilohertz, okay? That's a tone, a sine wave that approximately sounds like ooh. That's approximately, I sing terribly, but that's approximately 1,000 hertz, 1 kilohertz, and then you measure that, and in the professional world, that would have to come in at -4 decibels per volt. Basically, you want to make things sound good. That's the half science that I always promised I would do to myself in the show. Now let's get on to see how I got what I got. Now basically, this here is going to come up over here, and this, come on, here we go. Digital Performer is a powerful, powerful program, and I can increase the magnification. This little blip here is actually, let me solo that. Now that little blip makes an awful lot of, packs an awful lot of wallop for its size. Just to give you, the way they show it. This is magnified. Realistically speaking, if you were to go where, here, each one of these, there's 4 beats per measure. So there's 1, 2, 3, 4. That's these 4. 1, 2, 3, 4. And they don't even last a full beat. Otherwise, at this tempo, and I'm at a slow tempo, I'm at 70, let's see. My eyes are failing. I'm at 76 beats per minute. That's BPM. So, at 76, the kick doesn't take much room up, but it sounds. Boom, boom, 3, 4, 1, 2, 3, 4. And you can count them off and follow them in the counter. And as I've soloed that sound, so now what have I done? Good Lord, what have I done? I like this. This is called Lay Down. It's at 76 beats per minute, and it's somewhere around D. It's either D flat or C sharp. I don't know. I'm not that much on music theory. I spent all my time on engineering theory. But what I've done in order to get that sound, well, Let's take a listen. So we'll open up. This is a channel strip. And if you followed my show at all, which I don't expect you have, now you see I've chosen the famous 50 hertz, and I've put the gain at 3 o'clock, which is roughly around 10 dB. I have found that the relationship between a live, real analog version of this plugin is much more powerful, and I wouldn't have used that much. I may be using too much as it is. Who knows? I've just decided that that's how much I wanted 50 hertz, and I've cut somewhere between 1.5 and 2 kilohertz to get rid of the snap and tubby. You see, when you get around those 1 and 2 kilohertz, it's still the low mids or the high lows. I call them the low, well, they're generally considered the low mids. But it had a knocking sound, so I cut. And that made the kick deeper. And this here is your cue. Oh, that was the end of the song. Now, again, the cue is the amount, the width, the amount of frequencies also affected by the gain. Alright, this can be a narrow band or a wide band, depending upon what you want. I've chose a little bit of a wide band. If we take it and we go down narrow, oh, I'm sorry, this is narrow. It doesn't have quite the same effect because at this point I'm basically hitting 2 or 3 frequencies. So I go up. Here I'm just using the top end of this loop. And it only comes in and out. Those are production decisions. I would just say, I'm busy, I'm booked. Sorry, I can't make the studio that, you know. And if they got to a point where they said, well, I'll change the time, I'd really want you to do that, I would accommodate them. You know, there were very few artists that I did not actually at thecube@.com. And you people probably know a lot more about webs and web addresses than I do. We're almost at an hour's point, but I don't want to go out with just like this. Well, you know what? Let me sign off for this recording, because I have been recording. Thank you, and we'll continue on. I'll just append the end of it, because I think I have to do some rebooting here. I don't know what. Reboot the page again? Go live? See if that works. I've just started rebroadcasting via USTREAM. That hasn't seemed to help either. So I'm going to sign off now. I'd like to mention I also on Sundays appear on IC Weekly at 11 p.m. Eastern Standard Time, and another music show, which is an amazing idea thought up by Ian Husband and Rich Wildman, better known as 8-Month Malfunction and Illuminator to the iCompositions.com fans. Well, it came back on for a second and then went away. I hate when that happens. Let's see if I can get it back. As you can tell, I don't want to, I don't want to give up. We still got a lot to do. And it's not letting me do it. Okay. Let's try it again. Let's see what we get. We're not getting anything. Ah, well, I'm showing something up in the preview window. So maybe something will come back. Ah, there we go. All right. So we are back, and we will continue to broadcast until they knock down the door and drag me away screaming. I just want to see the significance of the lag, and I will play. I don't have to hear it, I just have to see the faders move. And that'll tell me whether we're really broadcasting sound or not. Ah, okay. Well, it seems like you've been able to hear me throughout the most of the show anyway. So, but we were into definitions of jobs. And let me check, make sure I'm still recording. Am I still recording? Yes, I am. God bless me. All right. And yeah, I saw briefly the music, the faders move, so we're not frozen. And so, in pure concrete, cement, so that there's no vibration. It's just solid sound coming out live.